This presentation is produced by Amugi, an international manufacturer of high-performance tools including taps, end mills, thread mills, tool holders, work holders, and gauges. This presentation will demonstrate high-performance machining in pre-hardened steel at 32 Rockwell. All tools are clamped with either an Amugi shrink fit or an Amugi power grip tool holding system. The first procedure is high-feed circular pocketing with an insert-style face mill called Time S-Cut. Time S-Cut inserts have 4 usable cutting edges, but what's really interesting about the inserts is their chip thinning geometry, which enables really high-speed milling. During this operation, cutting speed is 980 surface feet per minute, and feed rate is 472 inches per minute. Chip per tooth, 41 thousandths of an inch. You'll also notice that even though the machine is moving really fast and making really big chips, there's a very mellow machine sound. This is a characteristic of the cutting edge's eased entry and exit from the material, made possible by the chip thinning geometry. Next, an irregularly shaped pocket and an irregularly shaped slot will be produced using a solid carbide multi-jet cut end mill. Multi-jet cut is an HPC style tool with roughing optimized geometry that produces short, easy to handle chips. It also comes with IKZ channels to deliver coolant through the tool. The result is a true high productivity end mill. For example, this 10mm tool is operating with a cutting speed of 650 surface feet per minute and a feed rate of 78 inches per minute at an axial depth of 1 times diameter for a material removal rate of 12 cubic inches per minute. That's really fast, which is obvious while watching how quickly the pocket is formed. And now a long, irregular slot is being cut. Again, it's very interesting to see how fast this can be done. The next maneuver is really cool. An HPC jet-cut solid carbide end mill will do climb and conventional milling at an axial depth of 2 times diameter. At this depth and feed rate, chip evacuation is very important. Otherwise, clogging will cause failure. However, thanks to the special flute design and support from an Amugi cold air nozzle, this operation is completed without danger to the tool or the part. Despite its high productivity design, HPC jet cut is also capable of producing very good surface finish, which will be demonstrated once the roughing is completed. And now the finish pass, still cutting at 2 times diameter. Notice the stability. There's no chattering even though a large milling area is being used. Now 5 holes will be drilled in preparation for the following tapping operation, during which an M8 tap, specially designed for dry or MQL situations, will be used. Notice the chip formation and ejection. The very well-formed chip moves immediately away from the tool and the part. Also, there isn't any squeaking or squealing, even though lubrication is not being used. The tap is running at 65 surface feet per minute, which is the design speed for this tool and this material, and is a practical operating speed even in high production scenarios, though it does require high-quality tool holding, like the Amugi Power Grip soft synchro tap holder used here. Here again is multi-jet cut. This time cutting at 1.5 times diameter, 650 surface feet per minute, and 78 inches per minute. It's producing a stud for an external thread milling application later in the presentation. In this operation, it's easy to see the size and formation of the chips, and they look really good. This is a very important characteristic of a high productivity milling tool. Now an Amugi HSC jet cut Taurus end mill is producing a ring slot at full machine speed. Cutting speed is 1,030 surface feet per minute and 961 inches per minute. Next, a 10-degree taper is added to the pocket walls, which demonstrates the usefulness of a 5-axis machine. Multi-jet cut is again used. This time, it's machining a ring slot using feed rates similar to the other operations, but it's still interesting to see how fast the slot appears in the material. Again, chamfering is being done with a 5-axis and an Amugi HSC jet cut end mill. One interesting thing about this procedure is that the inside and outside of the ring will both be chamfered, which means making tapers at opposite angles, but this is done without changing the orientation of the table. Next, an M48x2 thread will be produced with an Amugi Threadzol insert-style single-plane thread mill. Thread mills of this type have many advantages. Versatility is one of the biggest advantages. It's possible to machine inch and metric threads in multiple pitches and diameters, both in left-hand and right-hand directions, while having full control over tolerances, all with the same tool. The single-plane cutters also produce very low radial pressure, which means less deflection and the ability to machine hard material. Now, 2 circular pockets will be produced. However, it's easy to notice that the tool isn't moving in a circle. Instead, it's following what looks like an odd stuttering path. The entrance approach is being made with a reversing half helix, which is similar to the way stairs in a stairwell switch back on themselves between floors. This technique produces a more level floor because the total ramp height is half what it would be with a helical entrance, meaning more room for better chip evacuation. Chip evacuation is also supported by air through the central coolant channel, and we can see that this combination very efficiently removes all the chips. Of course, chip evacuation is even harder to accomplish when the diameter of the hole is very close to the diameter of the tool, because then there's less clearance to get the chips out of the hole past the tool. As the second smaller hole is machined, the same efficient chip evacuation is obvious, despite the small clearance, highlighting the performance of this configuration. Now, HPC jet cut will be used to machine 2 open circular slots using yet another technique. Despite its silly appearance, this approach reduces milling forces and increases tool life. The tool is running at 650 surface feet per minute and 118 inches per minute. Now, a fixed-pitch Amugi GF thread mill will be used to produce both M32 by 1.5 and M16 by 1.5 internal threads. Of course, this implies that almost any diameter hole can be threaded with a 1.5 pitch using this tool. The GF thread mill can also produce left and right-hand threads. The open circular pockets provide a nice view of the machining that occurs during the thread milling process. In preparation for an external thread milling operation, a nice finish is applied to the stud using an Amugi HPC jet cut end mill. Finally, another fixed pitch Amugi GF thread mill will machine M20 by 1.5 external threads on the stud. The program includes a Higby feature to remove the first imperfect thread. This presentation demonstrated a lot of machining. Every operation was dry machining in 32 Rockwell steel. There were 8 pocketing and slotting techniques demonstrated, including time S-cut, making huge chips at 472 inches per minute, multi-jet cut performing really impressive material removal rates, and HSC jet cut running at 1,030 surface feet and 961 inches per minute. Also shown was how a single thread mill can machine a variety of diameters, pitches, and directions. The Erco MQL tap was also demonstrated, highlighting how this specially engineered tap can cut all day long at 65 surface feet per minute without coolant. That's a lot of interesting machining, and we hope it inspires you to think about the performance potential that can be achieved in your own machining environment. If you have any questions, feel free to contact us by phone or email. Thanks for watching.